Welcome. Thank you for coming. All right, we're going to wait a few minutes and then get started. For those of you who are wondering what this presentation is about, my name is Dmitry Polyakovsky, and I'll be speaking about using Redis with ElasticSearch, and I'm going to touch on the new feature called Redis Streams. Previously, I gave talks on using Redis as a cache, background job queue, or a database for rapidly changing data. If you're interested in those topics, come talk to me. I'll be willing to answer questions after my presentation. But this time, I want to talk about how to use Redis together with ElasticSearch. And I'm going to talk about this new feature called Redis Streams. A little bit about me. I'm originally from Ukraine, but I live in Seattle. I run the Seattle Redis meetup. If anybody from Seattle and you're interested, please come talk to me as well. I'm a software engineer. You guys can follow me on Twitter. Read my blog. You'll find a lot of articles which have similar content to this presentation. And if you're interested, this URL will get you the slides of this talk. A quick Redis survey. How many people used Redis for less than a year? 2, 3 years? OK, more than that? All right, wow. Caching. Anybody using Redis as a cache? Queue. PubSub. Wow. Any other use cases? Modules. Oh. How about PubSub? How about, I'm sorry?
Membership testing.
Oh, interesting. Session storage? Cool. Oh, wow. Again, the way I think about Redis, it's a Swiss Army knife. It's got a lot of really cool features. I can use it for a variety of tasks. And then there are certain things that it's not as good at. Just like a Swiss Army knife, just because it has a little saw doesn't mean you should try to cut 2x4s with it. How many people have used Elasticsearch? OK, so everybody familiar with Elk Stack, Elastic, Log, Stash, Kibana? So very quick overview. Elastic, based on Lucene. You have documents that go into indexes. It can be sharded and replicated between nodes and cluster. You get scale out and some data durability in case of server loss. Here's a very high-level diagram. You get some data, you process it, index it, and it can be searched via cluster or even clusters, plural. Logstash started as a simple tool. Take the logs and stash them in Elastic. Much easier to analyze. It grew into a very powerful ETL pipeline that has several hundred plugins for inputs from different sources, filters, transformations, and outputs. So for example, you can take data from an HTTP endpoint, a database, a file system, RabbitMQ, Kafka, many others, run it through some transformation filters, and send it to a variety of destinations. And if you want like a really easy Redis Elastic integration, you can use Redis input-output plugin, and you can put it in front of your Redis. You can put Redis in front of Elasticsearch and basically just keep pushing stuff into Redis list. Here's a simple config file. And what it'll do is it'll just keep the data there, and then your Logstash will just start grabbing things off that list. And you can easily protect your Elastic instance from a huge increase in traffic if you experience those. Kibana, dashboard, visualizations, ad hoc searches, ability to export data. Here's a screenshot. We are analyzing Apache logs so we can do some geolocation on them. Oh, in a different screen, but here's basically like breakdowns by country status. So very easy to build, very easy to customize. You don't have to write any code to do this. I want to clarify that this talk is not about using Redis or Elasticsearch, because there are certain tasks like auto-completion or geo-search that you can do with either technology. And instead, what I want to do is focus on using Redis with Elastic for time series data. Anybody work with time series data? Great. Basically, events that occur over time, IoT of things, various metrics from advertising systems. So I'm going to talk about using Redis Streams, which is a new feature. Anybody heard of Redis Streams? Anybody played around with it or attended the other training sessions? OK, so I'm going to touch on that. And RediSearch module, people heard of that? OK, and last, I'm going to show you what you can do in Elastic with data once you get data there and how you can build some dashboards in Kibana without writing code. How many of you have built reporting systems? How many of you enjoyed the ever-changing reporting requirements? Oh, now we need to group data by day versus by hour, et cetera. And it's inevitable. So using a tool like Kibana, you can make those changes easily. Or even better, you can train your business users how to do it themselves. The general theme is that we have hot data that's going to live in Redis. It's things that are changing very rapidly, things that have just happened seconds ago. The warm data is going to live in Elastic. This is where we're going to store it for a much longer period of time. We're going to analyze it differently, maybe, a lot of ad hoc analysis done by a different team, perhaps. And it's also a lot cheaper to store it because it's not going to be in RAM, but on disk. And then the cold data is going to go to somewhere like S3. Elastic has some nice tools for you to snapshot data over there. So this presentation is based on a real system that I'm building at my day job. But to make things more interesting, I decided to use Stack Overflow and their public data sets. We're going to drill in on 3 questions. What are people searching for? Like technologies, Redis, Memcache, which I used as tags on Stack Overflow. Where are they searching from? We're going to take the IPs and do some basic geolocation to lat long and to zip code. And last, when are they searching? So here's a sample dashboard that somebody showed up on the screen, at Stack Overflow could be using. Oh, this data is based on the Stack Overflow public data set, but I had to make up a little bit of it or randomly generate it for the demo purposes. For example, this data is actually Stack Overflow, so somebody searched for JavaScript 1.5 million times, but the zip codes, I just randomly generated some. So we have here 2 leaderboards, one for tags and one for zip codes. Is anybody familiar with leaderboards and sorted sets? Oh, everybody familiar, right? Okay, and we can present it in a tabular format or as charts. And here we have a bunch of counters by day of week and hour of day. So behind the scenes, Redis uses sorted sets to store the data. I have a sorted set called search tag, and members of this sorted set are the tags or technologies, and scores are the number of time it was searched for. So I keep incrementing it every time a search occurs. And same for zip codes. I increment the search zip code sorted set. By the way, if you guys have questions, just feel free to ask. Okay? And then we have strings, which we're using as counters. So we have one for search. We have 24 counters by hour of day and 7 counters for day of week. To capture these metrics in Redis, we're going to add a little bit of code to our Stack Overflow application. We use the increby command on the sorted sets. So &tag is the actual tag, like Elastic or AWS. And zip code will be something like 98101. And then we're also going to increment the appropriate hour of day and day of week. So pretty easy to write this code. Pretty easy to store it. It's going to be fast. It's going to be real time. We're going to build a simple UI on top of it. The biggest downside of this approach is that there's no way to drill in on this data. Like, there's no way to say how many searches were done for Java yesterday from this specific zip code, because we're just not storing that level of granularity in the current Redis data structures. So this is where Redis Streams can come in handy. If you want to run Redis Streams, you got to grab the latest unstable branch and just run make locally. And think of Streams as an alternative to Apache Kafka. Anybody use Kafka? I actually haven't, so wow, that's great. So you have time series data where you have key value pairs, and each item in a stream does not need to have the same fields. And each item in a stream will have a unique timestamp. We're going to modify our code like this. We will say the key is going to be search log, which is our naming convention, and then it's going to be date, just like we're rotating log files on a file system. The fields are going to be zip code and actual value and tag and actual value. So I'm just passing it to Redis as an array. And then we're going to call this new xadd command. Again, you have to run the latest Redis unstable. We're specifying a star attribute here. What that'll do is tell Redis to automatically create a unique ID. You could optionally specify your own IDs, and it'll work, but then you have to worry about ensuring the uniqueness and also ensuring that they're incrementing. So for example, if you insert an item with ID 4, and then you try to insert another item with ID 4, it will fail. Or if you try to insert an item with ID 3, that will also fail. Now, once we've inserted this data using xadd command, we can fire up Redis CLI and use xrange to extract it. So we're specifying xRange, giving it a key, which is search log and date, and then using minus plus attributes. That basically tells Redis to bring us everything from that key, from the beginning to the end. So be careful with running it on a real production system, because this is essentially an equivalent of opening an entire log file for the day in a text editor. You can get back a lot of data. But what you get back, it looks kind of like this. You will have these IDs, and then the key value pairs. Again, you don't have to have this be the same, so here we were able to capture zip code, and here, for some reason, we don't know which zip code this search came from. It's not a big deal for Redis Streams. But the IDs look like this. This is the timestamp in milliseconds, dash, and then a unique sequence number that's going to be ever incrementing. So in this case, these two events occurred at exactly the same millisecond, but Redis Streams still gave it a unique ID, but incrementing it from -0 to -1. Any questions so far? Okay. To access this data in an application, we also use xRange command. We again build a key, search log date format. And we're going to specify a starting ID of an hour ago, based on a timestamp, and ending ID of a minute ago, because that is the range that we care about. And then we query Redis using xRange start ID end ID command. It'll bring back us all of those records. We could theoretically specify time in the future. It just won't bring us back anything past now. Yes, go ahead.
Does that assume that the xRange, the composition of the millisecond, the discriminator, this is only doing a millisecond, right?
Yeah, so yes, you can, for example, let's say a timestamp is 123 dash, let's say it's time 123, very beginning of time at 1970, right? And you say 123, Redis says, oh, I have 123-0. No problem. I'll give you 123-0 items, and 123-1, and 124, dash, et cetera, et cetera. Anything greater or equal to. So, and it's the same thing applies if you specify your own IDs. So theoretically, you could have auto-incrementing IDs. It's just a lot more work to do it yourself. Any questions besides that? Okay. So yeah, so this will give us data for that from 1 hour ago till 1 minute ago, so 59 minutes of data. And we're going to use this approach to move data from Redis to Elasticsearch. As I said, hot data stays in Redis, warm moves to Elastic. So we're going to keep data in Redis for, let's say, 7 days, and then run a nightly background process where we say, OK, let's grab data. Let's go to the Redis key from 7 days ago. And since we don't want to bring back all items for the day because of performance considerations, we're going to specify another parameter called count. And we're going to simply loop through this. We're starting at minus, going to plus, but with a count of 100 that brings back the first 100 records. Then we're doing some processing on them, sending them to Elastic. Then we take the last item ID, split it on the dash, increment the sequence number by 1, and use it as the next starting ID in the next iteration. So if hypothetically the last item comes back with ID 123-1, we are going to say the next starting ID is 123-2. So a little bit more work we can do on the client, but this keeps the API for Redis Streams very simple. So. Another option is to use xRevRange command, where we're saying give me everything from end to beginning, and we're specifying plus to minus. And we can easily grab the last item in a stream by saying just count 1, or the last 10 items. So this way we know the last thing that happened that day. As an alternative to xRange, we can use xRead. And think of that as like a firehose way to move data in real time. How many have used Redis lists? Or pub/sub? So the big downside with using those mechanisms is that once you pop the item off a list, it's gone. You can't have multiple consumers grabbing the data of the same list because only one of them will get it. And sometimes maybe that's exactly what you want. Like, let's say you're running background jobs and you don't care which worker processes the job, but you may have a situation where you want all consumers to receive this data. You can use pub/sub for that, but the problem with pub/sub is that one of the client disconnects and is no longer listening to a channel. There's no way it can get the data. So using xRead, you can blog for, in this case, 5,000 milliseconds. You can specify which streams you're listening to with this key parameter. And then $sign is a special argument that tells it basically, give me the latest. You could have said, give me everything at 0 or give me everything at 1 hour ago, and would have just walked that stream and grabbed all the data. But the individual items, they still remain in Redis stream. So you can go back and forth within that data structure and read whatever you want. And this way I can build a real-time kind of fire hose system of moving data from Redis to Elastic or another data store. Personally, I just feel a little bit more comfortable with the X range command. Just kind of gives me a little bit more control of when I run it. And I'm a little concerned about overwhelming for the downstream system with all of a sudden a flood of data from Redis stream. There are other useful features. For example, you can have a capped stream to storing the, let's say, last 1,000 searches that occurred. So you will say MAXLEN parameter, specify 1,000. Again, same syntax of specifying a star to tell Redis streams to generate its own unique ID. And another optional thing you can do is specify this tilde attribute. That will tell Redis streams to keep approximately 1,000 records, and it's OK to go a little bit over. So it's going to do the purging of excess items in the background. So occasionally you might have 1,005 or 1,010 items in that stream. And if you only care about displaying 1,000 items on the UI, you can then specify a count of 1,000 for that stream, and that will bring back 1,000 records only. OK? Keep moving? OK. XLAN gives you the size of the stream. So what you can do is you can loop through all items, all keys in Redis that fit a particular pattern, and call XLAN on each one. You just have to be careful to make sure that all the keys are stream items. So for example, if you had a list or a hash that also was search log something, this would obviously break. But this way you can easily display on the UI, and you'll see it later in my presentation, all the logs or streams and how many records there are in each one. XDEL gives the ability to unique each item in a stream. So you specify the key of a stream, a date, search log, and then individual ID, and you can remove just one item. Xtrim allows you to shrink it a little bit, so you only keep 10,000 items in this case. And you can do the same option with MAXLEN and tilde, and it will, see here I said trim it to 10,000, but it actually trimmed it to 10,015. So there was a little bit of leftover. But having that tilde operator improves the performance. So it just depends on what you need. Xinfo gives you basic stats about the stream, like the size, last item, first item, and so on. OK, let's do another demo. Oops. So here are the streams. I'm showing here the last 10 searches with capped stream. Here's the timestamp-based ID, zip code, and tag. And here I'm showing all of the search logs that I'm storing in Redis and the size of each one. And I can click on each one of these and see the actual contents of each and every item with the IDs and the fields. Can you guys see it? Do you want me to zoom in? Good? OK. Are there any questions about streams? There. This is more interesting. All right. Let's keep moving. So I can think of a lot. Oh, I'm sorry. Go ahead. Yes. Sorry, can you speak up?
To automatically generate the unique ID. So
Yep.
is there any side effect when you have a Redis cluster?
The key will be in the same stream.
Oh, okay.
So it will do whatever replication in the background. Yeah. Are you talking about an active-active cluster? Or just a standard Redis master and then some replicas?
Probably the cluster.
Cluster,
like
yeah. So again, don't think of these as separate keys. Right? Again, this is all one large key, like a set or a list. And there's no limit, actually, to a size of the stream, just a limited amount of RAM. So, but again, it's all going to be generated in one key, and then Redis will snapshot it to disk, replicate it, etc.
Okay, thank you.
Did that answer your question?
Yeah.
OK. So lots of use cases. So as I said, I'm using this as part of my data processing pipeline for doing some real-time and near real-time data analytics on various advertising metrics. But this could be applied to IoT types data. Or you can do it for threat analysis. You know, you're keeping track of which IPs hit your servers. You want to make those lightning-fast decisions based on the counters you keep in Redis. And then you also want to send it to ElasticSearch, as I'll show you guys later, for a longer-term analysis. Or you might want to be tracking a location over time, and then you can take advantage of Redis geo capabilities. So you're recording position of each bus or car or one of those bike shares like every minute, and you only keep last 60 minutes of data, so you can see where that particular vehicle has traveled in the last hour. Can be very useful with something like a capped stream and geo proximity. GeoRadius, GeoAdd. Anybody done geo stuff with Redis? Okay, right. So real time. Okay, so any more questions about Redis Streams? Okay. So now we are storing data in Redis Streams. How can we make it searchable? Because we can just like look inside each stream, but what if we want to know how many searches were done for Java or C++, right? We want to be able to take those streams and index them somehow. How many people have worked with RediSearch module? Okay, so how many people know about modules? All right, so very quick overview. They were announced a couple years ago. They officially shipped with Redis 4 last summer. So you have to run Redis 4, and you have to be able to install that module on the server. If you want to grab RediSearch module, just clone the repo or download it from GitHub. You got to compile it, and then you use this load module command in redis.conf file. So as we've just heard, soon these modules will be available in Redis Cloud. Hopefully they'll also be available in other hosted Redis solutions, but until then you got to be able to get to the server where you're running Redis. Think of them as WordPress plugins. And once we install RediSearch module, we get additional commands. So the namespace prefix ft dot. So ft create will create an index. And one note of caution is with RediSearch indexes, you have to specify the schema at the time of creation of the index. So it's fixed. And once you create the index, you can add documents to it. What I'm doing here is I'm passing the stream item ID as the document ID to RediSearch indexes. You will see it shortly. And then I'm parsing it, passing that same ID, timestamp dash sequence number, to the ElasticSearch document. So it gives me ability to cross-reference and match the documents with stream items if I need to. You don't have to do it. You can, for example, ElasticSearch will generate its own unique IDs for documents if you don't want to pass your own ID. But anyway, after that, I call ft-ed. I specify the index name, ID, and specify the fields such as zip code and tag Redis. That's the data that I want to index. And then I call ft-search. I specify the index name, the query, and I can optionally do a limit with the beginning and end parameters. And if I want to get rid of a document, I just call delete. In Redis, data looks like this. RediSearch on its own will create a couple of special data types. One is called ft index, and one is called ft inverted index. So it's going to be like each term that you search, like a zip code or technology tag, will become a key, and that'll contain references to which documents it lives in. And optionally, you can tell RediSearch to store the content of a document. For that, it will use plain Redis hash. So here it is. I have my hash with a key, timestamp dash 0 sequence number, and the value is zip code and tag Python. Since I'm storing data inside Redis Streams in this case, I can choose to save RAM and simply do no save option with RediSearch. And this way, when I do a search, I'm only going to get back this ID. And from this ID, I can figure out which stream it belongs to by decoding it back to a timestamp and deriving which date it is for, and then go into that stream, grab that item, and get the contents that I care about, such as this was a search from zip code 31643 for tag Python. But if you want to keep things simple, just store the document, or if your data is somewhere else, maybe you're indexing a bunch of files. The challenge is that the Redis streams are 1 per day, so I'm storing 7 separate keys. And when I'm done with them, I delete the old stale data, or I move it to ElasticSearch. And I created only one RediSearch index. So when I'm going to delete the old stream, I need to either go through every single item in that stream and call individual delete commands to delete the documents in RediSearch, which is quite painful. Or another option is I can create multiple RediSearch indexes. And this part actually proved to be more difficult than I thought it was going to be, and while I've prototyped it, I did not fully implement this, and I probably will not implement this. But here's how to do it, in case you need to. Basically, you create a client in your application, you pass in the time when you initialize this client, and you can't just assume that the time is now. You could be processing data for files from, I don't know, a week ago. So then you have some methods that wrap basic RediSearch commands, like ft_create becomes create, and there's some additional logic to check if that index exists, because the RediSearch will error out if you try to create an index that already is present. You specify schema, and then you can also, basically this method will create the index. Now that we created the index, we can start adding documents to it, and we can make this method smart to always add. When you add a document, it'll always create the index if the index doesn't already exist. And same pattern behind the scenes in Redis. It will create multiple sets of these keys, and now it's going to include the date in these keys. Search is also more complicated because you can't just query one index. You have to figure out what are all the indexes in Redis that are following this pattern. So I'm querying Redis keys for this search log star naming pattern. I get them back, I do some formatting, and then I loop through these indexes and I call ft_search on each one. So I query today's index, I query yesterday's index, and so on and so forth. I bring back data from the last 7 days of indexes that I have in RediSearch. I then merge it together and I present it to the UI. Quite a bit of work. And you have to account for a lot of things. For example, if somebody passes a limit saying I only want the first 10 items, you don't query for 10 items for each and every index. You have to keep track of how many were returned from the first index and only grab the additional ones from the second or third index, if that's what you need. So it made me appreciate how much work Elasticsearch gives me right out of the box. But the cool thing about this approach is now our data cleanup becomes much easier. That we drop the one key, which is the Redis stream, and that's all going to be. Redis on its own will delete all items in there. And then we call this ft_drop command, and RediSearch will take care of cleaning up all the individual Redis keys for that index. So that's the positive. Another demo. So we're going to see what were the searches for PHP. So in here, okay. So here are all the items. Oh, excuse me, here are all the documents from my RediSearch. I use the timestamp-based ID to derive the time of when the search occurred. I grab the zip code and the tag. So you can see all of these are for PHP. And we can also do a search for a particular zip code. Here are all the searches from that zip code, and here are all the tags that people searched for. Are there questions about RediSearch? Okay. So now we've spent quite a bit of effort moving data from Redis Streams to Elasticsearch via either the xread firehose, constantly running process, or via this background nightly process where we're just grabbing the previous day's data or data from 7 days ago and copying that over. What can we do with it in Elastic? Well, quite a lot. And as I mentioned, the good thing about it is we can do it without writing any code, or even we don't have to do it. We can train other people how to do it. So here's a quick demo. I have this data randomly generated on 10,000 searches. Can you guys see it? You want me to zoom in? Oops. Okay, so we can drill in on each document. Here's the ID, timestamp dash sequence. Here's the naming pattern that I'm following. Same with the search log and date. I did some data enrichment in that process. I added latitude and longitude based on the zip code. But we can see the original tags and zip code values here. We can even look at it in raw JSON if we want to. We can do a lot of really cool things here. Like, for example, we want to only show these columns. So this can be exported into Excel spreadsheets. Oh, as I said, this was randomly generated, so we have this ridiculously flat graph, and in reality, you will have a lot more peaks and valleys because people searches vary by time of day. We can add some cool filters, or when I say we, I mean our customers, business users. So, for example, tag is Redis. So only 14 searches in the time period. Or we can disable this tag, and this filter, and add another filter. Tag is Elastic. Oh, excuse me, tag keyword. "25 searches for ElasticSearch in a time." We can save these. We can send this as a link to somebody. So like, nice short URL. Obviously, localhost will not work, but at work, that's what I literally do. I'll get like an email from a business user saying, "Hey, can you help me get this data?" And I'll just build this search, and I'll just email it to them, and then show them how to tweak some parameters so they can customize it themselves. Another thing you can do is build all kinds of visualizations. For example, you saw me that I took the zip codes and I enriched it with latitude and longitude when I moved data from Redis to Elastic. So here's a geo map of where all these searches are coming from, and these zip codes all happen to be in California. But the way I build it is I use this geo hash aggregation, and I specified location field, which is a lot long for a specific zip code. Another cool visualization is a pie chart. How can you have anything without a pie chart? This is a very boring pie chart because the data was randomly generated, so it's ridiculously uniform. But in reality, these are much more interesting pie charts. Tag cloud is cool. So here, you guys want to build a visualization? Yes? All right, let's do it quickly. So let's see, new one. What do we want? How about a table, data table? And we're going to pick search log as our indexes. So we see there's 10,000 total. We're going to split this on terms and say tag, and we want the top 15. And there it is. We can just export it into spreadsheet if we wanted to right there. So there is a bit of a learning curve with Kibana, but once you get over it, you can do all kinds of cool stuff. And we can take our visualizations and combine them into dashboards. So here, we can build a new dashboard and just add visualizations to it, coordinate map. And now, oops. So there we can, I actually saved this visualization before. Here it is. We can go full screen, put it up on a big monitor somewhere in the office, and have everybody say, wow. Are there any questions about Elastic or Kibana part of the presentation? Don't be shy. Go ahead. Oh, sorry, can we get a microphone?
Regarding the geolocation part, based on public IP, is there a possibility with Kibana to do it, or?
So what I did is I basically took those IPs and I just downloaded some public data sets, mapping them to zip codes, I think, and then I mapped zip codes to lat long, so it's a very like center of that.
Okay, there is kind of plugin for Kibana to do it?
Yeah, this is all standard Kibana. Like you go on their website, you find tons of tutorials. I didn't write any code. I just basically took the data, and I think they have some kind of an API that actually provides a geolocation map in real time too. Yeah. So, but basically, when I send the data over from my Redis to Elastic, I wrote a little bit of code, but there's actually a log stash filter called GeoIP. So if you download like a MaxMine data sets,
yeah, exactly.
it will just automatically grab that MAXLEN database, and it will automatically look at your IP address and do the mapping. So what I did was actually more code that I had needed to, but I wanted to do it as part of my application, not as part of my log stash pipeline.
Okay.
Does that answer your question?
Yeah, exactly.
Okay.
MAXLEN.
MAXLEN, yeah.
It's
So
also
you can
like
use a
for Graylog
MAXLEN
and
data
stuff.
set to map IPs to locations. And then once you get the lat long in here, or long lat, whichever you prefer.
And just, yeah, second question
Yes.
was regarding Redis Search and ElasticSearch. You used both at this?
I'm experimenting with both. So this is, again, this is based on a real-time system. I'm slowly rolling out these features. Like, I don't have the streams in production, my production environment yet, because it's not generally available. So, but I have been running it for quite a while, and it works great. I'm thinking about whether I'm going to implement RediSearch, whether I need this kind of a speed, or whether, you know, a slight time delay is acceptable for business stakeholders.
Okay.
So, but this was kind of me researching how would I search the data that I'm storing in Redis.
Okay.
And it's possible with RediSearch module. But if you just need, but if you're okay with having a more near real-time system, it's simpler to use Redis as an ephemeral store that will be used by your application to keep track of all this data as you're processing it, and then have the long-term storage and this kind of dashboarding capabilities in Elastic with Kibana.
Okay.
Did that answer your question?
Totally.
Go ahead. Oh, sorry.
Is there a visualizer for Redis? Maybe not a Kibana,
So they
but a Kibana Lite?
I was about to get to that. So I asked that very question for the Elastic people. I went to ElasticCon a couple months ago. No, Kibana talks directly to ElasticSearch. However, what they recently launched is this new Vega, V-E-G-A language. It's kind of a scripting language that runs in a browser. And what it does is it allows you to query API endpoints. So one option is if you don't want to move data from Redis to Elastic, you simply build some kind of very lightweight API that sits in front of Redis. This Vega client essentially queries this API and says, hey, give me this, here's the API endpoint, here's the parameters that I care about, gets back that JSON, and then simply renders it in this Vega canvas, I think it's called. I'm not sure about it. So, but yes, I think Kibana is a really cool tool, and if we could use it to visualize Redis data, it'd be really great. I'm also looking into that Redash tool that they demoed during one of the other talks. So that looks interesting. R-E-dash, so.
Redash is made basically around RediSearch.
Yes. Is that a separate tool or just a hosted service? I wasn't sure.
Redash is a separate tool made by a separate company, actually.
Okay.
It's like an entirely different project, and they use it. They use it in all the demos, so I guess it's pretty cool.
Yeah.
It looks way better than what they used in their previous demos.
Yeah.
That's. I'm not from Redis Labs, so it's like.
Yeah, I've used a few like browser type tools to view and delete the contents of Redis databases, which is much more useful when you're troubleshooting something. But it's very hard to edit data because the data types are just so different. So I'm definitely going to check out Redash myself. I don't know how rich its graphing capabilities are, but you know, it'd be cool to be able to do something like this, or
It's not Kibana yet.
yeah, or like this. Well, I don't know if it's even possible for it to be Kibana because you just have entirely different data structure underneath it. The data structures. Other questions? Okay, well, if you guys want to talk to me afterwards, I'll be available for questions. Thank you for coming. Oh, another question?
I just want you to bring up the slide where it contains a link to the presentation.
Oh, sure. Oh, one more thing. Sorry, I forgot. So I mentioned this whole idea of cold data. So if you're interested in cold data with this ElasticSearch, they have a tool called Curator that helps you automate the process of snapshotting data from Elastic, basically taking different Elastic indexes and just throwing them to S3 and potentially restoring them from there. I have a whole bunch of these business rules at work where, you know, I have to keep some data for a very long time. So I have a whole bunch of this essentially backed up to S3, and then I have an option to restore. And here's some useful links, and you wanted the bit.ly URL. There you go. Thank you for coming.